IsoGrid, the next generation of composite technology. Today, we live in a world where technology and innovation is measured in seconds and fractions of grams instead of days or pounds. What we may have thought was the lightest and fastest technology available one day is often obsolete the next. Nowhere is the push for more technology more prevalent than in the world of enthusiast sports. Today's athletes demand more from their equipment than ever before. Whether it's an athlete at the very pinnacle of their sport or just another weekend warrior, the expectation of their equipment is the same. They want it to be lighter, faster, stronger. In the drive to meet the demands of these passionate athletes, engineers and designers have worked hard to find the right materials from which to create. Enter the era of carbon fiber and composite technology. Its unique structure and flexibility has given engineers and designers a clean canvas from which to create. No other material lends itself better to the demands of complex designs than carbon fiber. But not all carbon fiber structures offer equal performance. IsoGrid technology allows designers to push the performance levels of conventional composites by using an array of carbon fiber ribs to reinforce an ultra-thin, double-butted outer shell, reducing total structure weight while yielding tubes that are stronger and stiffer than conventional composite tubes. IsoGrid is a patented technology that allows products to be made lighter, stronger, and stiffer by creating a totally new technique in how they are both designed and made. IsoGrid technology incorporates a grid of integral raised composite ribs that permit the wall thickness of conventional composite products to be made thinner, thereby reducing weight. The orientation, size, and density of the ribs allow engineers to tune the performance levels to the specific requirements of each application. Simply stated, IsoGrid allows designers to put material where they need it and remove it from where they don't. The construction of an IsoGrid tube is a painstaking process that involves hours of skilled labor and meticulous attention to detail. Each layer of an IsoGrid tube has been engineered for a specific purpose. The IsoGrid material and individual carbon plies are pre-cut into a kit, which is then used to build the tube. Once the correct mandrel and bladder is assembled, the IsoGrid carbon fiber ribs are oriented according to the design by wrapping them around the mandrel and bladder. After the IsoGrid layer has been positioned, it is then covered by various layers of unidirectional carbon fiber material that is used to form the outer shell element of the IsoGrid tube. Once all the layers have been rolled onto the mandrel assembly, the tube can now be prepared for the complementary bifusion process. First, a special layer of film adhesive is placed at each end to co-mold the titanium lugs during molding. The titanium lugs, which have been specially prepared in an offline operation, are then positioned over the uncured carbon materials to ensure the precise engagement of carbon and titanium. Before placing the entire assembly into the female mold, special carbon inserts are placed in the cutout locations of the titanium lugs to help lock the two materials in place. The inserts and inner carbon tube become permanently joined during the molding cycle. In the final step of the fabrication process, the tube is removed from the mold after cure and then cleaned and prepared for welding into a bike frame. The welding process requires the highest level of skill, as the artisan must closely monitor temperatures throughout the process to ensure each tube's integrity. IsoGrid was developed specifically for weight-critical applications such as bicycle frames. where its network of raised ribs can effectively change the ride characteristics of a given tube and ultimately the frame itself. The deflection that can occur in thin-walled tubes that do not have IsoGrid's reinforcement is tremendous and can lead to significant energy loss as demonstrated in this animation. The change in color of the tubes in this 3D model reflects what happens to the various tubes in a non-IsoGrid frame when it is under load. The pink and red areas represent the significant amounts of distortion present in various tubes, and also represents the loss of pedaling energy on each stroke as the frame flexes. This 3D model is an IsoGrid frame with the exact same geometry and under the exact same pedaling loads as the previous example. Note the much lower amount of pink and red areas, which again represent the amount of distortion the frame has under load. The end result is that the IsoGrid tubes are more effectively resisting the loads being placed on them. This is IsoGrid at work. The ribbed array is working to stiffen and strengthen each tube as it's put under load. More energy transfer, better acceleration, and far greater climbing ability are the benefits of this patented technology. IsoGrid, the next generation of composite technology.